Hello, Justin Marish here.
Hi everybody, I'm Dr. Shelby.
I'm Dr. Southern.
This is Gwen Bauman.
All right, for this demonstration we will be looking at the dehydration of sugar.
I'm here to make slime with you.
Dry ice.
A chemical called luminol.
Thermite reaction.
All right, for this demonstration we will be looking at the dehydration of sugar. There are 50 grams of sugar in the beaker on the left, and we will dehydrate that sugar using concentrated sulfuric acid. There are 50 milliliters of concentrated sulfuric acid in the other beaker. I'm Dr. Southern, and carrying out this demo will be Sunny. Hi, Sunny. And Josiah. Hi, Josiah. All right, so they're going to go ahead and pour the concentrated sulfuric acid into the beaker containing the sugar. And we'll immediately see the sugar start to change color. This reaction takes a little while to get going, so we'll need to be a little patient to see the full results. But we can see that the sugar is decomposing as it darkens, and eventually it will all turn completely black, at which point we will have generated just the carbon from the original sugar. And once the reaction has generated enough heat, we'll actually start producing some steam, and we'll see that column of carbon rise out of the beaker. All right, we now see it.
Oh, my gosh. Wow.
All right, good job, Sunny. Good job. Keep it going. Very exciting. All right, so we see that once we generate enough heat, then we can start to see that boiling, and our column of carbon has risen out of the beaker. Thanks, Sunny, for catching that and making sure it doesn't fall over. All right, thank you for watching.
Hello, Justin Marish here, Professor of Biochemistry at the DePaul University Department of Chemistry and Biochemistry, and I want to show you some of my favorite things to do for fun with dry ice. The first thing to think about with dry ice is just how cold it is. Here I am dropping some dry ice in ethanol, which has a freezing point well below that of the -78 of dry ice, and I'm going to see the effect it has on a soft material like this gummy worm here. Now, dry ice is frozen carbon dioxide, and we consider it to be dry because carbon dioxide sublimes from solid to gas without going through a liquid at atmospheric pressure. Here's the gummy worm cooling off now. Listen to how hard that thing is. And it smashes just like glass. And I mean, it really smashes like glass. There were bits of gummy worm all over the place. Took a while to clean up. Another cool thing I like about dry ice is atmospheric fog. You just throw some dry ice into some hot water, and the carbon dioxide and the water vapor that condenses around it are both heavier than air, and so they make this cool, creeping fog effect that I never get tired of. Look at that. It's so great. Okay, so what we just saw was that dry ice can make a lot of gas. Well, gas plus soap equals bubbles. So what I'm doing here is mixing some dish detergent in with some hot water, and about to throw in some dry ice, and whoa! Oh man. Oh, this is not going to be fun to clean up. Oh, but it's so good. All that foggy vapor. Like those big, huge bubbles there. Those are pretty cool. And it just keeps going. Look at that. So here I've got another beaker with hot water and dry ice in it, but I've soaked a paper towel in some soapy water to try to get a big soap bubble to form on top. And there we go. I've never done this before, so it took me a few tries to get this to work, but look at that. What's going to happen? Oh, so nice. After doing a few of those in a beaker, I had to take it up a notch and try it in a large crystallizing dish. And here we go. Look at all that vapor inside the bubble. So after watching that last demo for a while, I tried to figure out a way I can make dropping bubbles. Now here's what I came up with. Check this out. So I dipped the end of that rubber tubing in some soap, and there you go. This is just like pure Hollywood mad science lab. Whoa! Did you see that one roll? Amazing. Now, following on this theme of bubbles, here's a way to demonstrate that carbon dioxide is heavier than air because it fills the bowl of this dry ice bucket. Bubbles will just land and float there. Look at that. Here's another one. There. Cool, right? Another cool thing about carbon dioxide is that we use it in fire extinguishers because it is a product of combustion and therefore cannot burn. So when we put a match near carbon dioxide, it just goes right out. Have you ever thought of containing dry ice in a microcentrifuge tube? I don't know if the sound came through, but those things are almost as loud as firecrackers going off. Definitely don't try this without safety glasses. After they all exploded, I gathered up the pieces, and as you can see, the pressure of the gas absolutely destroys these things. Now, I've seen that dry ice sublimes at atmospheric pressure, but look what happens when you allow it to build up pressure in a closed container as it evaporates. Above about 6 atmospheres, you start to actually see liquid carbon dioxide. Take a look at that. Now, this is something I do not advise that you do without a lot of safety precautions, because the container can explode pretty violently, as you saw before. Now when I release the pressure, all that liquid just turns into just fluffy dry ice snow. Another property of dry ice is that it dissolves in water to create carbonic acid. This is responsible for ocean acidification, and also we can demonstrate it here by just dropping some dry ice in some universal pH indicator. You can see it turn from purple through green and yellow, and then finally to red. And finally, this one is my personal favorite. Here we have some basic water. I drop in some dry ice, and the jets of CO2 cause a beautiful color change as it acidifies the water.
This is Gwen Bauman, and I'm going to do a demonstration called the Thermite reaction. And in this, we're going to take the iron 3 oxide, this red solid, and we're going to mix it with some aluminum solid, which is this powder. And with some heat, we're going to go ahead and form some aluminum oxide.
Magnetic vacuum.
For this demonstration, we'll be looking at the reaction of a solution containing a chemical called luminol. You can see in the light blue solution that's sitting on the table, that solution contains both luminol and a little bit of copper 2 ions. Those copper 2 ions give it the light blue color. The solution that appears clear contains a little bit of hydrogen peroxide, and we're going to mix these two solutions together to observe a chemical reaction. So rather than me, Dr. Southern, doing the actual chemical reaction, to DePaul undergraduate students, Sunny, hi Sunny, and Josiah, hi Josiah, will be mixing these two chemicals together. And feel free to ooh and ah from home as we carry out this reaction. All right, boys, take it away. Timing, 1, 2, 3, and go. All right. As we can see, the combination of these two chemicals produces a luminescent solution. The hydrogen peroxide in the presence of metal ions catalyzes the production of an excited state molecule, luminol. And as that luminol relaxes, it produces the beautiful blue color that we are seeing. Over time, the solution that appears to be glowing so brightly and beautifully will eventually become a rather unattractive green solution. But for now, we can observe the pretty blue color. And thank you, boys, very much for carrying out that demonstration.
Here's some copper. Labeled calcium. I think it's labeled lithium. Woo. And I think this one is sodium. And the bottle's not working. It was working this a minute. Let's go back to lithium. That was good to know. All right.
Hi, everybody.